So continuing with the previous one, we know that W is equals to Fs cos theta. So work is dependent on force, magnitude of force, magnitude of displacement, and the angle between the force and the direction of the displacement. So there are special cases. First case is that if displacement is in the direction of the force, then if the displacement direction of the force, then theta is equal to 0. If theta is 0, cos 0 is 1. Accordingly, work will be equal to F into S. Okay, so that was the first thing. For example, will be all the things like freely falling body. So क्या हो रहा है जब ये नीचे गिर रहा है, gravitational force is pulling it downwards. So when you're pulling downward, the body is moving in the direction of the force. That's why it is going to be positive work done. Similarly, a coolie does work on the load when he raises it upwards again. यानी coolie ने इसे उठाया और इसे इसके सिर पे रखा, तो he is doing the work against the gravity. But so basically, when he is lifting it up, he is lifting it up in such a way the force and the displacement both are in the same direction. So accordingly, he is doing work when he is lifting it up away from above the body. Now, in this case and in the earlier case of the gravitational force, you can see over here that the force which is going to be exerted will be equal to the mass, will be the weight of the body. Okay, so if I consider this one is falling downwards, so this is equal to the weight. The force is nothing but the weight of the body. So the weight of the body over here is nothing but W weight. Weight is equals to M into G, where weight is also a kind of a force. So that's why we say F is equals to M into G, and the displacement what you are going to see over here, S is nothing but the height of the object, height from which it is being falling. So अगर height of the यानी वो अगर 5th floor से नीचे गिर रहा है तो वो जितना height वो 5th floor का है वो height हो जाएगा. That's why the work done will be equal to F into S के बदले हो जाएगा mgh. So W is equals to mgh is another formula what we'll be having when the body is freely falling or it is lifted upwards. If I am lifting this thing upwards, at that time what is the amount of force I am applying equal to the weight of the body? So weight of the body is how much? M into G, because it is this weight. Why the weight of the body? Because mass to hai plus the gravitational force which is acting on it. I am doing the work against the gravitational force. So when I am doing the work against the gravitational force, I am doing the work equal to the weight of the body. So M into G into the height, that is the displacement which the body is going to have. So accordingly we see that when your body is freely falling or you are raising it up, then the work done will be mgh. Okay, which is same as Fs but easier to solve a problem if I know that this is the formula rather than taking F is equal to M into G and then say S is equal to H and then doing it. Yeah, better it will be this way. Similarly, if a body revolves in the circular path under influence of force, on completing one round, the displacement becomes 0. So the work done will be 0. So when will the work done 0? When the displacement is 0. That means अगर एक किसी ने round चक्कर मारा, तो एक round complete करने के बाद में the displacement becomes 0. So my S becomes 0. So force कितना भी apply किया हो, फिर भी the work done will be 0. So there is again a special condition which is going to take place when the work done is 0. Another condition over here is a case wherein the displacement is normal to the force, means force applied is this way but the displacement is this way. So this particular thing is going to change your answer, because if cos theta mein theta is 90 degree, you know that cos 90 is 0. If cos 90 is 0, automatically the whole thing becomes 0. So work done will be 0. So when the work done is in such a way that the force is perpendicular to the body, or is perpendicular not to the body but basically perpendicular to the direction of the force or direction of the body, motion of the body, or direction to the perpendicular to the displacement of the body, then we say that the work done will be 0. So the case over here is that when a coolie walks on the horizontal ground while carrying a load on his head, no work is done against the force of gravity. No, there is a displacement from here to here. वो डिस्प्लेसमेंट है, पर अगेंस्ट द ग्रेविटी क्या है, बिकॉज ही द बॉडी दिस इज द फ्लोर, दिस इज द कुली एंड ही इज हैविंग हिज हेड ओवर हियर, सो समझो ऐसे करके समझो यहाँ पे उसने रखा है, एंड व्हेन ही इज वॉकिंग एट दैट टाइम, नो डाउट फ्रॉम हियर टू हियर द डिस्प्लेसमेंट इज देयर, सो दैट इज अ डिफरेंट वर्क डन, बट against the gravity over here, what is happening, it is the same. So body is trying to go downwards because of its weight, and he is just hold it at that particular position. He is not making it go upwards or downwards. So with the gravity there is no change in the displacement. Accordingly we say that the work done will be zero with respect to the gravity. It is only with respect to the gravity that the work done is zero. So when a coolie walks on the horizontal ground while carrying a load on his head, no work is done against the force of gravity, because the displacement of the load is normal to the direction of the force of gravity, which is vertically downwards. The coolie but does work against the force of friction when he moves with the load. So when he is moving ahead, so against the force of friction he does the work, but not against the gravity. Similarly, when a body moves a circular path in a horizontal plane, no work is done, since the centripetal force of the body at an instant is directed towards the center of the circular path. So here, and the displacement of at that instance is along the tangent to the circular path, that is normal to the direction of the body as shown in the figure. It is for this reason that a circular path, the kinetic energy and hence the speed of the body does not change although the force acts on the body. So you can see that in a circular path. So again, something unique. First of all, we saw that in a circular path, when a complete rotation is completed, at that time the work done is zero. So if I see a circular path, when he starts from here and ends over here, he starts from here and ends over here, then of course the work done is equals to zero, and we have no doubt about it, because the S was equals to zero. But now let's consider any point, any particular point. So if I see that at this particular point, now at this particular point, what is the force of the centripetal force acting over here? This is the centripetal force, and this force over here is going to give rise to this movement. Accordingly, what is the direction of the motion? The direction of motion is tangential. This is perpendicular. Okay, you can see that the direction of the motion is perpendicular to the force. And what will happen with this? What is that? If the direction of force is perpendicular, cos 90 is 0. Accordingly, we see that in case of uniform circular motion, because the force is always tangential to the direction of the motion, that is the reason the work done will be 0. So over here in this case, because cos 90 is equals to 0, so W is equals to Fs 9 into 0, hence 0. So that is why we see that the work done by a force which is normal to the direction of the motion is always going to be 0. It is also for this reason that a circular path, the kinetic energy and hence the speed of the body does not change although the force acts on the body. Okay? The force is continuously acting on the body. So actually what should happen? It should go faster and faster, but it doesn't happen. Why it doesn't happen? Because the work done is 0. इसलिए kinetic energy जो है वो constant रहता है. It does not change. The speed and the kinetic energy does not change because it is not in the same direction. See, when you are pushing something and you keep on pushing at the same force again and again, you will find that the body will start moving with the accelerated motion. But when you are going around and you are pulling and putting it round and round, at that time the speed does not change because of the reason that the direction of the motion is not in the direction of the force. Okay. So conditions, accordingly we can see there are two main conditions for the work done to be 0. When is the work done can be 0? Is first thing is that when there is no displacement. First thing, when displacement is 0. No work done when displacement is 0. And secondly, if the displacement is perpendicular to the force. So when the displacement is normal to the direction of the force, then the work done is 0. Now we see the third part over here, third case. So the first case was when cos theta was 0. The second case is when cos theta is 90. Now let's take a condition wherein that if the displacement is in the opposite direction to the force, this is something unique. मैंने फोर्स अप्लाई किया इधर से ऐसे और वो ऐसे आ रहा है. When is it possible? Like for example, you are trying to, a car is in a slope and you are trying to push it, but even if you are pushing it, the body is going to go down the slope. Okay, if such a thing is happening, means your work done is bringing is not sufficient enough to push it upwards and the body is going downwards. So that's why you can see that when the displacement is in the direction opposite to the force, then theta over here, that means you have this particular thing over here that you are trying to move this thing on this particular plane, but wo ja raha hai exactly ulta way. That means the theta over here will be equal to 180 degrees, and this is very important for you to know that cos 180 is nothing but -1. Okay, cos 180 degree is -1. That is why you will find that the work done, so work done will be negative. So it will be negative. Okay, so work done over here, W will be negative if the theta is 180 degrees. That means the theta is opposite to the direction of the force, or sorry, not theta, but the displacement is opposite to the direction of the force. For example, when a body moves on the surface, the force of friction between the body and the surface is in direction opposite to the motion of the body. Therefore, work done by the force of friction is negative. When a ball of mass m thrown upwards from A to B to a height h, the direction of force of gravity mg, so the work done by the force of gravity mg in the displacement h is negative. Means I take this body, I throw it upwards. When I throw it upwards, I am doing the work against the gravity. Gravity is trying to pull it downwards and I am pushing it upwards. So मैंने positive work किया, but gravity ने कैसा work किया? Negative work किया. So gravitation, for the work done by the gravity when the body is thrown upwards is negative. So that is why it will be minus mgh. So you find over here that you will be able to get this particular idea that there are three conditions, that if cos theta is 0, work done is 0. If cos theta is 0, or that means cos theta is 0, that is cos 90 is 0, therefore it is perpendicular, then the work done will be 0. If cos theta is equal to 1, that is when cos 0 is equal to 1. So if theta is equal to 0 degrees, then the work done is equal to f into s, and if it is minus 180 degree, the work will be negative. So accordingly, we have this particular conditions over here, and even if you have a displacement to force to displacement over here, then the slope over the work done will be equal to the area of the slope. So if I have got a particular, let's say that suppose I draw a graph of force to displacement. So this is the force and this is the displacement, and if the graph is like this, then this is the area of the graph. So the area of the graph is nothing but f into s. So that is the work done. So work done will be given by the area enclosed in the graph. So even if the the graph is like this is s and this is f, and the graph is like this, so constant force and making the body move, then this area over here is going to be f into s. So work done, if I want to find out the work done by the force displacement graph, okay, if I want to find out the work done by force displacement graph, then the area enclosed with the x-axis of the graph will give me the work done. Okay, so area of the graph gives me the work done. I already explained you that the work done due to gravity will be nothing but mgh. Let's erase that. So work done by gravity is mgh. Also now let us see the units of work done. So unit of work done, we know that W is equal to Fs cos theta. Uska value का जरूरत नहीं है. Newton is the force. This is meter. So Newton meter should be the SI unit. This SI unit Newton meter is given the name joule. So joule is the SI unit of the, that's why we can say that 1 joule is equals to 1 Newton into 1 meter. Okay, 1 joule is equals to 1 Newton into 1 meter. We can have multiple units also like kilojoule and gigajoule, megajoule, वो भी कर सकते हैं. और CGS units में it will be this way, that is equals to 1 dyne, and this will be in centimeters. So this is SI and this is CGS. So 1 dyne on centimeter is given as 1 erg. So 1 erg is 1 dyne into 1 centimeter. So we can define 1 joule as 1 joule of work is said to be done when a force of 1 Newton displaces a body by 1 meter. Okay, if the force, a joule of 1 joule of work is said to be done when a force of 1 Newton displaces a body through a distance of 1 meter in the direction of the force. Similarly, 1 erg of force will be 1 erg of work is said to be done when a force of 1 dyne displaces the body by 1 centimeter in the direction of the force. So that is the SI and the CGS unit of work. We can also have the relationship between joule and erg. We know that 1 joule is equals to 1 Newton into 1 meter. Now you know 1 joule and dyne is 10 raised to 5. So 10 raised to 5 dyne makes 1 Newton, and 100 centimeters make 1 meter. So that's why 1 joule is equals to 10 raised to 7 erg. That's the relationship between joule and erg. Okay, so that is how we work over here, that joule is Newton meter, erg is dyne centimeter, Newton to dyne is 10 raised to 5, meter to centimeter is 10 raised to 2, therefore 1 joule is equal to 10 raised to 7 erg. That was the units of work. Now we see the next part of the chapter, that is power. So now power, it is the capacity to do work. Okay, the power is basically a scalar, again a scalar quantity. Power is a scalar quantity, same as the work. So work के बाद अभी power. Okay, sorry, not capacity. Capacity to work is energy. This I just misplaced. Mistaken it. Power is the rate of doing work. कितना जल्दी काम किया is what power means. So power is rate of work done, or rate at which work, rate of doing work, rate of doing work. Okay, it's a scalar quantity, and because it's a rate of doing work, now we always know that any particular formula which says whenever there is any definition which gives a rate of change of or rate of doing something, that means we are relating it to time. Okay, whenever we are saying rate of doing something, rate of change of, at that time we are always relating that particular physical quantity with time. So here we are relating the particular quantity, which quantity? Work. We are relating the work with time. Accordingly, we say that power is equals to work upon time. So that will be the main formula for power. So power is equals to work upon time. So it is nothing but the work done W upon time taken T. So P is equals to W upon T is the formula for power. So power spent by a source is measured as the amount of work done in a source in 1 second, or is equal to the rate of doing work in 1 second. So work is equals to, if W work is done in time T, if W work is done in time T, then power is equals to W upon T. That becomes the formula for this. So accordingly we see that the power is dependent on two things. One is the amount of work done, and secondly is the time taken to complete that work. Okay, time taken to complete that work is also very important. So that is done with the help of power. So if a machine does a given amount of work in less time, then more power is spent in it. If I can do some particular work, okay, like simple thing, you are cycling. And because you are cycling, you are able to go from one place to another place in a particular time. Now if I take a bike, okay, motorbike, and do the same thing, what is going to happen? I am going to reach faster, the same distance. If I am reaching faster, what has happened is I have utilized more power. May not be my own muscular power, as in the case of cycling, but I have used more power in the form of a fuel. Okay, so that's why it will depend upon what time taken, according to which the power required will be more or less. So if a coolie takes 1 minute to lift a load to the roof of a bus, while another coolie takes 2 minutes to lift the load to the same bus, the work done by both the coolie is same. देखिए क्या था work done? Force into displacement. Displacement क्या है? Same है. First ground floor to the top of the bus. दोनों ने same काम किया है. So work done is same. पर एक ने 1 मिनट में किया, दूसरे ने 2 मिनट में किया. तो जिसने कम टाइम में किया उसका पावर ज्यादा है. So coolie 1 is more powerful than coolie 2. So that means that the power spent by coolie A is twice the power spent by coolie B, because the coolie A does the work at double the rate in half the time. That is half the time. Okay, he has done double the rate because he completed it in 2 minutes, 1 minute, whether the other one completed it in 2 minutes. So accordingly, we say that W is equals to B is equals to W upon T. Now let's see something more over here. I have over here W is equals to F into S. So and P is equals to W upon T. So let's replace this. P is equals to F into S upon T. Now what is S upon T? That is displacement upon time is velocity. That's why power can also be given as F into V. Understood? Power can also be given as force into the average speed of that particular object. So this gives us another formula that power is equals to F into V. Now we come to the units of power. We know work is in joule. This is in second. So power is equals to joule per second. The joule per second over here is given as a new name as watt. W-A-T-T, in the name of James Watt. Okay. So that's why this is nothing but capital W. So I need to put in small. Okay. So watt is the unit. Hence we can define watt as 1 joule of work done in 1 second. 1 joule of work done in 1 second. Then the power spent is said to be 1 watt. Or 1 watt of power is said to be utilized when the work done is 1 joule in time period 1 second. Okay. Of course, we can have the greater power units also, kilowatt, megawatt, gigawatt, and smaller unit also, milliwatt, microwatt. All this is possible. Similarly, there could be also the CGS units. So you know CGS unit of joule is erg, and that of this is second. So power can also be erg per second, but there is no other name given to this particular thing. So it will just remain erg per second. Now there is one more unit of power, which is the unit used by mechanical engineers for the machineries, and that is given as horsepower. You must have heard this name a lot because they may tell you, अरे इतने HP का मोटर है या इतना BHP is the is that of a bike. Bike इतने BHP का engine है. Maybe if you have heard it, the horsepower HP over here, that इतने HP का मोटर है, 5 HP या 6 HP का मोटर चाहिए, तो that HP over here is nothing but horsepower, and it has got a specific unit that 1 horsepower is equals to 746 watt. Okay, it is 746 watt, which can be given as 0.746 kilowatt. Okay, so 1 HP is equals to 746 watt or 0.76 kilowatt. Accordingly, we can have the differentiation between work and power. Work done by a force is equal to the product of force and the displacement in the direction of force. Power of a source is the rate of doing work by it. Okay. Next is work done does not depend on time taken. Okay, it does not depend on time. Whereas power depends on the time in which the work is done. Third, SI unit of work is joule, whereas SI unit of power is watt. So this was about the part power of the chapter. Now we come to the last part of the chapter, and that is the energy. Now that is what I mistook it, that thing last time was, yeah, energy is the capacity to do work. Okay, so this is the definition of energy. Energy is capacity to do work. So this is the energy, which is nothing but capacity to do work. Okay, so we see over here that energy, see, when I say that I can do this work, means what? It means that I have the power to do that much work. At the same time, I need that much amount of strength to complete that work. So that means if I am able to do that much work, I have that much energy that I can do that amount of work. That's why we say that energy is nothing but the capacity to do work. Okay, so a body capable of doing work is said to be possessing some energy. The energy possessed by the body is measured by the amount of work that the body can perform. When a body does work, its energy decreases, while if the work is done on the body, its energy increases. So when I push this thing over here, I utilize my energy. At the same time, this got its own energy. Like for example, from year to year, when I put it over here, at that time I have increased its potential energy, so it has the capacity to fall down. Okay, so we'll come to that when we see the potential and kinetic energy. So it means that whenever work is done, there is always a transfer of energy. The energy and work are related to each other. Or we can just define energy as the capacity to do work. Again, work is scalar, so energy is also scalar quantity. Energy is a scalar quantity, same as work. So since over here, if I say that energy is the same thing as power, automatically energy will also be having the same units of power. So accordingly, energy and power has the same units, that it will be joule. Sorry, this way, joule and erg. So joule and erg are the units of energy. So SI unit will be joule and the CGS unit will be erg. The bigger unit of this will be given as, if it is electrical circuits and all, it will be watt hour. Okay, it is watt hour for this thing, or maybe kilowatt hour. So kilowatt hour, watt hour, kWh. These are the examples for the kind of energy which is over here. Over here we see that 1 watt hour can be easily converted into this form. That's so 1 watt hour is nothing but 1 joule per second. So 1 joule per second into 1 hour. So that means 1 joule per second into 1 hour is 3600 seconds. So it is 36000 seconds. So this will be seconds. So second gets cancelled. This means joule. So 1 watt hour is equal to 3600 joule, which is nothing but 3.6 kilojoule. Okay, this is one part. And if I talk about kilowatt hour, so that means kilowatt hour is nothing but 1000 watt hour. So that means 1 kilowatt hour will be 3.6 into 10 raised to, now this is already, okay, we'll do it this way, 3600 into 1000 joule, which is 3.6 into 1, 2, 3, 4, 5, 6 into 10 raised to 6 joule. Okay, so 1 kilowatt hour is 3.6 into 10 raised to 6 joule. We have to note that there is no transfer of energy if a body is acted upon a force normally to the direction of its displacement. For example, for a body moving in a circular path, centrifugal force is normal to its displacement and work done is 0. So there is no transfer of energy. So when I am moving it in circular motion, displacement is 0, plus it is also the direction is perpendicular. So no energy transfer takes place. That is also the reason why the satellites, or we can say the earth moving around the sun, or the moon moving around the earth, is not having gain in the energy, because it is always in a uniform circular motion. So there is no transfer of energy. So watt and kilowatt are the units of power, while watt hour and kilowatt are the units of energy, since power into time is work, because we know over here that power is equal to work upon time. So work is equal to power into time, but work is equal to energy, so therefore energy is equal to power into time. We can consider it this particular way. Okay, that is why we have got that watt hour. Watt hour is power into time. Watt is power, time is hour. Now, because energy can be of different forms, accordingly we see that in case of a heat energy supplied, then the units will be calorie. So 1 calorie of heat energy required is the amount of energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. And it is given that 1 kilocalorie is equal to 1000 calories equal to 4180 joule. Similarly, electron volt is the energy of the atomic particles. So I can just write that down, so easier for you to remember. Understand also. So it is 1 calorie is equal to 4.18 joule. Okay, so that is one part, that is for heat. This is related to heat. Okay, the another one is electron volt. Okay, electron volt is another one which the energy of the atomic particles in very small is very small, so it is measured in electron volt. So the energy of the atom, so atom वो होता है ना आयनेशन पोटेंशियल वगैरह कि कितना एनर्जी से वो निकालता है या लेता है वगैरह वगैरह, दैट एनर्जी व्हाट वी आर टॉकिंग अबाउट, or the energy when it is going to give rise to the splitting of the electrons or splitting of the nucleus due to radioactivity. All those kind of energy are nothing but measured in electron volt, because the energy of an atom is very small. So that electron charge is this way, that 1 electron volt is equals to 1.6 into 10 raised to minus 19 joule. This thing, if you remember, this is the charge of 1 electron. 1 electron ka charge is 10 raised to, see, 1 electron is 1.6 into 10 raised to minus 19 coulomb. That is the charge present on each proton or electron. So that's why this is the particular coulomb into watt. So that is why electron volt, electron into volt will be this particular potential. Potential is the work done. So that's why it is W. So over here, let not go into detail of that thing right now. So you can see that you can just remember it this way, that 1 electron volt is equal to 1.6 into 10 to minus 19 joule, which is nothing but charge on the electron. So 1 electron volt is charge on the electron into 1 volt. So we can see the difference between energy and power. Energy of a body is the capacity to do work, whereas power of a source is the rate at which the work is energy is supplied by it. Energy does not depend on the time, whereas power depends on the time in which energy is spent. And SI unit of energy is joule, SI unit of power is watt. So this is the explanation of this particular part of the chapter, part A of physics, work, power, work, energy, power. Okay. Next video will be for the numericals of this particular chapter.